Hello everyone, welcome to my YouTube channel. I am Lisha studying in Sri Venkateshwara College of Engineering. I am here to explain about the Peterson's solution from the subject operating system, and its code is BCS 303. Introduction. Peterson's is a well-known algorithm in a concurrent programming designed to address the critical selection problem for two processes. It ensures mutual exclusion, meaning only one process can access shared resource at a time, preventing data corruption or inconsistencies. Developed by Gary L. Peterson in 1981. This solution demonstrates the synchronization can be achieved using only shared memory variable without relying on a special hardware instructions. Peterson's solution is a particular appreciated for its simplicity and its appearance to the three essential properties of a good synchronization mechanism. Mutual exclusion process, a bounded waiting, although primarily a theoretical tool, it remains an important concept for understanding the foundation of process synchronization and the challenges of concurrent programming. Key concept: critical selection problem. This arises when multiple processes need to access shared resource or data, and simultaneous access may cause inconsistency and corruption. Mutual expansion. Only one process is allowed in the critical selection at a time. Process. If no process is in the critical selection, others waiting to enter should not be indefinitely delayed. Bounded waiting. There must be a bound on the number of times other processes can enter their critical selection before a waiting process gets a turn. Peterson's solution mechanism. Peterson's solution works for two processes typically labeled P0 and P1, used two shared variables, flag 2, an array where flag I indicates it if process Pi wants to enter the critical selection. Turn, a variable indicating whose turn is to try entering the critical selection. Properties of Peterson's solution. Mutual exclusion granted since both processes cannot enter the critical solution simultaneously. Process ensure no indefinite blocking if the other person does not want to enter the critical selection. Bounded waiting guarantees a process will eventually enter the critical section. Analysis of a Peterson solution. This is a two-process solution. Let us consider two cooperative processes P1 and P2. The enter section and exit section are shown below. Initially, the value of inserted variables and turns variable is 0. Void entry selection. Int process. First is int other equal to 1 minus process. Interested process is equal to true. Then turn is equal to process, while interested others is equal to true and turn is equal to process. Critical section. Void exit section of int process. Sixth step is inserted process is equal to false. Initially, process P1 arrives and wants to enter into the critical selection. It sets into interested variable to true. Instructions line 3 and also set turn 1 line number 4 since the condition given in the line number 5 is completely satisfied by P1. Therefore, it will enter the critical section. P1 1, 2, 3, 4, 5 CS. Meanwhile, process P1 got permitted and process P2 got scheduled. P2 also want to enter in the critical section and executes instructions 1, 2, 3 and 4 of entry section. On instructions 5, it got struck since it doesn't satisfy the condition. Values of other inserted variables is still true. Therefore, it gets into the busy waiting. P2 1, 2, 3, 4, 5. P1 again got scheduled and finished the critical section by executing the instruction number 6, setting interest variable to false. Now if P2 checks, then it are going to satisfy the condition since the other processes are interested variables become false. P2 will also get enter to the critical section. P1 6, P2 5 CS. Any of the process may enter the critical section for multiple numbers of a time. Hence, the process occurs in cyclic order. Now let's discuss about the 4 important topics. Mutual expansion. This method provides mutual expansion for sure. In entry section, the while condition involves the criteria of 2 variables. Therefore, a person cannot enter in a critical section until the other process is interested and the process is in the last one to update the turn variable. Process. An uninterested process will never stop the other interested process for entering in the critical section. If the other process is also interested, then the process will wait. Bounded waiting. The inserted variable mechanism failed because it was not providing bounded waiting. However, in Peterson's solution, a deadlock can never happen because the process which first sets the turn variable will enter in the critical section for sure. Therefore, if a process is permitted after executing line number 4 of the entry section, then it will definitely get into a critical section in its next chance. Probability. This is the complete software solution and therefore it is portable on every hardware. Conclusion. Peterson's solution is a foundation algorithm in concurrent programming that elegantly solves the critical section problems for two processes. By relying on a simple shared variable and logical condition, it ensures mutual exclusion process and bounded waiting and making it an excellent example of software-based synchronization. While its practical applications can be limited in modern systems due to inefficient busy waiting and hardware adventures, Peterson's solution remains a crucial concept for understanding process synchronization and the principles of concurrent programming. It continued to serve as an educational tool and stepping stone for more advanced synchronization techniques. Thank you for watching my video. Please like, share and subscribe to my channel.